We'll proceed in pseudo multivariate calculus and we will see area vector into a spherical coordinates. Length vector, area vector into a spherical coordinate system. Length vector, area vector into a spherical coordinate system. That is the discussion, the topic that we will pursue. What is the length vector and what is area vector in a spherical coordinate system? Why you need that? I'm trying to find the area of this sphere. Consider this is a sphere. What is area of this sphere? Surface area of this sphere through a spherical coordinate system. There can be many ways people discuss. But to find the surface area of something, to find the area of something, we need to have two sides. One side is called width and one side is called length. Width into length gives the area of something. Okay, width into length. Width can be represented width and length. What is width of this and what is the length of this surface? That if I multiply, then I get area of this sphere. But this is called pseudo code. Pseudo code, if someone if someone trying to find the length of a curve, what is length of this curve? What is length of this curve? Okay, length of this curve. Length of this curve, this is curve is a line. What is length of a line? Okay, what is the length of a line? Length of a line is if I have 2 points on the line, then through Pythagoras theorem I can find length of the line. If this point is x1, y1 and this point is x2, y2, x1, y1 and x2, y2, then length of this line is x2 minus x1 whole square plus y2 minus y1 whole square root. That is the length of this line. I believe it is understandable. Okay, what is surface area of this? Surface area is length into width into length is surface area. Someone has to find width. Where is width of this and where is length of this? Okay, if I'm trying to find the length of this curve, then I took a simple case as a straight line and did the Pythagoras theorem and I found the length of the line. If I am trying to find the length of a surface area, I'll take a simplest case as a rectangle and width into height is the surface area. Makes sense? I believe it makes sense. Okay, now what is the length of this curve? Okay, to find the length, to find the surface area of this rectangle, to find the surface area of this rectangle, then width line into length line. This is length and this is width, W into L. If I multiply these two, so I am writing now the area of any 2D, area of any 2D shape where we have width and length. Area of any 2D shape, either it can be a sphere. How come you can calculate area of a sphere? Why width into length? Where is width of the sphere? If this is a surface of a sphere, where is the width of the sphere? You have to find out. We have to find out. But area means width into length is the area. Are you sure about it? That width into length is area? Yes, I'm sure about it. That width into length is area. If someone is trying to find area, if someone is trying to find area of a sphere, someone has to find what is area of this. I found the width. This is the width. This is the height. Multiply by width into length, you get the area. What is the area of a sphere? Try to find width somewhere and then length somewhere and multiply it, you get the area. This is called pseudo mathematics. Means if you're trying to find area of any complex shape, you just write on the paper. Area of any shape is width into length. Now question arising is how to find width and how to find length. If I take now let's take simple case of a rectangle. What is the width? Width is represented by a line. What is length? Length is represented by a line. This is represented by a line. This is represented by a line. If this is represented by a line, then what is the length of this line? If this line represents the width, what is length of this line? If length of this line from point x1, y1 to point x2, y2, if that is the 2 points on this line, the length of the line is x2 minus x1 whole square plus y2 minus y1 whole square root. Okay, consider x1 and y1 is 0 and x2, y2 is x and y. Then what is the length of this line? We started with the surface area of a sphere is width into length. Width is a line and length is a line. How to find width length and length length? Width consider as a straight line. If it is a straight line, then its length is, if this point is x1, y1 and this point is x2, y2 as per the Pythagoras theorem, it will be x2 minus x1 whole square plus y2 minus y1 whole square root. That is the length of this line. If this is the length of this line, consider x1, y1 as 0, 0, x2, y2 as x, y. In that sense, it becomes x minus 0 whole square plus y minus 0 whole square root. It becomes x square plus y square root. Oh, x square plus y square root. This is the length of a vector also. If I represent this line as a vector, and vector is passing from origin to point x, y, then it is xi plus yj. Length of xi plus yj vector is x square plus y square root. Then represent it as a vector. Who is stopping you? Okay. So the area of a rectangle is width into length. Width can be represented as a vector and length can be represented as b vector. A vector and multiplication will be replaced by cross product. There are two products for the vector. One is called cross product and one is called dot product. The cross product will give the area. A vector, that is a width vector, cross product with the length vector, that is b vector. A vector cross b vector is the area of a rectangle. This is what we see. This is a vector and this is b vector. Consider this is origin. Then this is b vector and this is a vector. If I do cross, or consider this is origin from my side, then this is a vector and this is b vector. If I do cross product of a vector and b vector, we get the area vector. A vector cross b vector, we get the area vector. Thank you very much. But do you know that the surface you are trying to calculate the area, that is a sphere, it is a round surface, it is not a flat surface. So if it is a flat surface, then area length vector, width vector and length vector. Okay, if it is a flat surface, then if it is a flat surface, then length vector and width vector, or width vector, length vector, straight vector, they give cross product of them, they gives the area vector. But what about if it becomes a curve? As per the pseudo mathematics, whatever we are writing step by step, it will not change. Okay, in that sense, again, this curve line, new curve, that straight line become a curve line. This curve line will not be this curve line will still be a vector, and this straight line become a curve line. A curve line. Okay, this will again be a b vector. Again, the curved surface area is a vector and b vector. A vector cross b vector will give the curved surface. Now, this straight line become a curved line. Means, earlier I had a straight line that was represented by a vector xi plus yj and x square plus y square root was the length. Now, this straight line was changed into a curved line. What is the length of this curve? What is the vector representation of this curve? If I get vector representation of this curve, then again a vector cross b vector will give the surface area of a curved surface, where a vector represents a curved line and b vector represents a curved line. This explanation is not available in any of the books. Okay, now in that sense, A vector cross product with the B vector will give the area of a curved surface, where A is the vector representation of a curved line and B is a vector representation of a curved line. What is vector representation of a curved line? If you see the curved line, if you see the curved line, then I've talked it many times. If you see the curved line, if you see the curved line, then x-axis, this is x-axis considered. Then there is a line equation for this curved line. This can be y equal to sine x, y equal to x square, and whatsoever. If it is like so, then what is the correct difference between this curved line and a straight line? Idea is there is a point on the curved line called x comma y, and this is 0. What is the curve length from 0 to x comma y? If I take a straight line connecting 0 and x comma y, and I calculate the magnitude of this vector, then it will give the length of this straight line rather than this curved line. What is the representation of this curve as a vector? So that calculating the magnitude of the vector will give the length of this line. Curve vector, if you see curve vector, whatever we are writing from the beginning, nowhere I can replace, it will go. This is the designing principle. You should be open for the extensibility but closed for the modification. Whatever we are writing from the beginning, width into length is the area, it will not change. Width is represented by A vector and length is represented by B vector. Cross product. We are going now step by step. Now A vector represent a curved line and B vector represent a curved line. In that sense, what is the vector representation of this curved line? Any vector is represented as xi plus yj, that we will not change. But what difference we see between a curved line and a straight line? Curved line and a straight line, that both are connecting origin and point x comma y. In curved line, y by x, everywhere y by x is different. Whereas for the straight line, if I take only a straight line connecting origin and x comma y by x, everywhere it is a constant. Same. So y by x looks like it is different from the straight line to curved line. So I have to represent this vector notation of a vector as xi plus yj into y by x, so that curve vector will come into the picture. Since xi plus yj can be written as x, if I take it out, it becomes I plus y by xj, bracket close into x. Or I can take out y out, then it will become x by yi plus j, bracket close, y into y, whatever. Now this is a curve, this is a vector representation of a curve. I plus y by xj, bracket close, into x, or x by yi plus j, bracket close, into y. These two are curve vector representation of a curve. If these are vector representation of a curve, then we can proceed upon. For a curved surface area, if one is A vector and another is B vector, then A vector cross B vector, A vector cross B vector, A cross B vector, this is the surface area vector. If this is surface vector area vector, A can be written as I plus dy by dx. I'm sorry, I plus y by xj, bracket close, into x. And b vector, which is along the y-axis, I can take out y. In that sense, it becomes x y y, x y y, I plus j, x by I plus j into dy into y. Or I can take full form x y z. If it is the line is lying in 3D, then it becomes I plus y by xj plus z by xk into x. That is the A vector. Cross product with x by yi plus j plus z by yk into y. If I calculate this cross product and then calculate this is called area vector. A vector cross B vector is the area vector, where A vector is I plus xi plus yj plus zk and B vector is xi plus yj plus zk. In A vector, I take out the x considering that A vector is parallel to x-axis. And in B vector, I take out y considering it is parallel to y-axis. Okay, anyone can do whatever it comes to its mind. Because after all, both are same xi plus yj plus zk. Now the A vector will become I plus y by xj plus z by xk multiplied by x cross product with x by yi plus j plus z by xk into y. Okay, now as per the mathematical fundamental, this is a length vector. Understandable, not understandable. This is called curve vector. I plus I plus y by xj plus z by xk bracket close into x cross product with another curve vector where y I am taking out in bracket x y y I plus j plus z by yk bracket close into y. Both are xi plus yj plus zk. If I do cross product of these two, it becomes area vector. If I want to find the net area, then it is magnitude of the area vector will give the area. What are you talking? Then this will give the magnitude of the surface area of a sphere. Yes, and we have done in the past video. Please watch our past video where we have talked about the area vector of a sphere through the cross product of two curve vectors. Okay, looks like you're very confident. Can you try in a spherical coordinate system? Spherical coordinate system. Okay, in a spherical coordinate system, again area vector is A vector cross B vector. What is A vector? In Cartesian coordinate system, A vector is a vector from origin to point x, y, z. That is the A vector. What is B vector? A point from origin to another point along the B. This is this is A vector and this is B vector. This is origin. In that sense, A vector is from origin one vector line and from origin another vector line. Considering it as a generic, then A vector is xi plus yj plus zk and B vector is again xi plus yj plus zk. If it is not generic, then someone can say x1i plus x2j plus z1k, x1i plus y1j plus x1i plus y1j plus z1k. That is the A vector. B vector is x2i plus y2j plus z2k. That is the B vector. A vector and B vector. Okay, if that is the scenario, A vector and B vector cross product gives the area. Let's find the position vector in a spherical coordinate system. Position vector in position vector position vector in the Cartesian coordinate system is xi plus yj plus zk. What is the position vector in a spherical coordinate system? For the A vector and B vector, this is a $1 trillion question. This is not available in any of the book. Anyone can try. This is not available in any of the book. If that is the scenario, we will try to find the kind of a spherical coordinate system. What spherical coordinate system? What is the A vector and B vector? Curve vector. Okay, spherical coordinate system, typically it has three components. One is called radius, one is called theta, and one is called phi. This is what is written in the book. But what we are talking, it is not written in the book. Coordinate system means 90 degree. They will cut at 90 degree. That is called coordinate system. If the 3D shape is represented by x-axis, y-axis and z-axis, then they are 90 degree to each other. If I say r, theta, phi are the three coordinate axes in a spherical coordinate system, they must cut at 90 degree. Not possible. If it is a sphere, consider this sphere is centered at the origin. This sphere is centered at the origin. The center of this sphere is the origin. From origin, there is any point here, P. From origin, if I draw a line to P, this point is X, Y, and Z. But we are talking about a spherical coordinate system. What this point will be? in a spherical coordinate system, whatever. If I connect the center of this, that is origin 0, 0, 0, to any point P here, there will be a line that will pass through. That line is the radius. Okay, that is the one component of the spherical coordinate system. Okay, if someone is novice, he does not know spherical coordinate system, how he can find out? Okay, he is seeing a sphere where he is, how to find coordinate system of any 3D? I am asking this question. Three dimension means it will have three sides. If this is a volume, then it has three sides. Three sides. Volume is area into height. That is the volume. Volume means area into height. Where height is one coordinate system and area has again two parts. Length into width. There are two coordinates. So total three coordinate system. How to find area, height, width, and length? Okay, if I'm talking about this 3D shape, if I'm talking about this 3D shape, okay, then what are the three components in the 3D shape? Three orthogonal components in the 3D shape. 3D shape is a volume which has the height and surface area. This is the surface area and height is the radius. If I take a sphere, the immediate thing that comes to our mind is the radius, because radius makes the sphere. Okay, but it does not come to our mind that the sphere is denoted by a volume, and volume has three sides. One is radius. What is other side? Everything can be represented in two items. If it is radius, then other item is area, and area is the surface area. No, surface area will break into two items. This circular spherical surface area, what are the two items through which this surface area is constituted? This is constituted through a vertical arc and horizontal arc. This is what anyone would see. If there is a circular area, a spherical area, looks like I can cut this. This is spherical area. I can cut in a vertical plane and I can cut in a horizontal plane. This is the two things. This is the thing that will come to anyone's mind immediately. You have to find two lines on this area, because area is formed by two lines, width into height. What are those? Then anyone will think cutting it into vertical plane and cutting into horizontal plane. That is the two lines. If I cut into vertical plane, then it will make a vertical circle. If I cut into vertical plane, if I cut into horizontal plane, it will make a horizontal circle. Means at any point if I have a horizontal arc and any point if I have a vertical arc, then these are the another two components, where vertical arc and horizontal arc, if this is the vertical arc and this is horizontal arc, they will cut each other at 90 degrees. Certainly, if this is the sphere maximum circle, if I go up, this is circle will become smaller and smaller and smaller. For the sphere in the centered at the origin in the xy plane, the circle will be maximum. If I go up, make a slice of the circle will be become smaller. Still, the vertical arc and horizontal arc will make 90 degree with each other. Okay, in that sense, if from center one radius is passing, then radius to the horizontal arc is 90 degree and radius to the vertical arc is again 90 degree. Means all three are 90 degree to each other. What all three? Theta, r and phi, wrong. R and horizontal arc and vertical arc, these three will make the orthogonal component. These actually the orthogonal component of a spherical component system is R, R, R phi and R sine phi theta. What are those? Actually, the three independent component of the spherical coordinate system is R, that is the radius, that starts from origin and it touches the sphere surface R, and then horizontal arc, and then vertical arc. These three are three vertical independent components of a spherical coordinate. If I see the horizontal arc, then it is whatever the radius in the horizontal side into theta. That is the horizontal arc. If this theta is 2 pi, then the full arc is 2 pi r. Similarly, the vertical arc, if from vertex, if from the vertex vertical, if it makes theta angle, this is vertical arc. This is vertical arc. Okay, if this is vertical arc, if I take any point P here, that is x comma y comma z, then this from the vertical vertex, this angle is phi degree. This angle is phi degree. This is radius. If this is the radius, then what is the length of this arc? If this is the radius, then what is length of this arc? This is the vertical arc. Then this is radius into angle called phi. Angle is in radian. If this is horizontal arc, if this is horizontal arc, then whatever is the radius into theta, that is the horizontal arc. If that is the case, now consider this is vertical arc and this is horizontal arc. And vertical arc, any point the radius is there. This radius can span from here to here, to here, 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 360 degrees. Now this radius is at angle phi. In that sense, vertical arc is r into phi. In that sense, r sine phi will fall, this radius will fall on xy plane. So on xy plane, the radius is r sine phi. If radius, I am taking any generic radius for a point x comma y comma z. Now r sine phi is the radius on the horizontal plane. R sine phi theta is the horizontal arc. If I take a constant radius r anywhere, so r phi is the vertical arc. R sine phi theta is the horizontal arc. In that sense, any point on this sphere through the spherical coordinate system, any point on this sphere through spherical coordinate system, I can represent as r comma r phi. I'm sorry, r sine phi theta comma r phi. What do you mean? Okay, then what is the this is the any point on the sphere. If any point on the sphere is x comma y comma z, then length vector is xi plus yj plus zk, or curve vector is I plus y by xj plus z by x, k bracket close into x, or j, x by yi plus j plus z by y, k bracket close y, whatever I take out. Okay, but main is point is x comma y comma z. Okay, or xi plus yj plus zk. Here point is r comma r sine phi theta comma r phi. This is not available in any of the book. Anyone can try. This is typically a spherical coordinate system. What is the vector representation of a line in the spherical coordinate? If a vector representation of a line in Cartesian coordinate system is xi plus yj plus zk, then vector representation of a line in the spherical coordinate system is r unit vector plus r sine phi theta into theta unit vector plus r phi unit vector. Makes sense? Or r vector comma r sine theta, r sine phi is angle from the vertical, r sine phi theta is angle on the horizontal plane, r sine phi theta vector plus r phi vector, or r unit vector plus r sine phi theta unit vector plus r phi unit vector. So that is considered. So that is considered as the kind of that is considered as the a vector representation of a curve of a line, straight line, in the vector representation of a straight line in the spherical coordinate system. Now, if I have a vector and b vector that makes the surface area, a vector and b vector. Now, these vectors will have independent component, variable component. One is theta and one is phi, because r is constant for a spherical area, if we're calculating the area, then r is constant. Theta will vary and phi will vary. In that sense, I have a vector cross b vector. A vector, if I try to calculate the surface area of a sphere, that area means multiplication of two vectors or cross product of two vectors. One vector is the phi vector and one vector is the theta vector. Okay, anyway, but vector representation of a point is r unit vector plus r sine phi theta unit vector plus r r phi unit vector. Now this is a vector and this is b vector. Now for a vector, if this is a straight line vector, if I want the curve vector, at one place we will take theta out and at another place we will take phi out. Okay, now cross product of r vector plus r sine phi theta vector plus r phi vector, cross product with r vector plus r sine phi theta vector plus r phi vector is the area vector. If this is the area vector, then calculate the cross product, calculate the magnitude of it, and then this will be the area, surface area of a sphere. Yes, try it. Now who is stopping it? Try it. Okay, then in one vector we will take theta out. Earlier in one vector we took x out. In another vector we took y out. In another vector we will take phi out. So it will become r by theta, r unit vector plus r sine phi theta went out, theta unit vector plus r phi by theta, phi unit vector. Cross product here I will take out phi. In that sense, r by phi r unit vector plus r sine phi theta by phi theta unit vector plus r phi will go away, r phi unit vector. If I do cross product of these two, one is theta outside and in braces r by theta r unit vector plus r sine phi theta unit vector, theta went away, plus r phi by theta phi unit vector. Cross product with in bracket r by phi r unit vector plus r r sine phi theta by phi theta unit vector plus r phi unit vector. Phi went out into phi. Okay, now we will do cross product of these two. Prior to that, we will change it into calculus now. Division will become differentiation and multiplication will become integration. So first one is r by theta, r unit vector. It will become dr by d theta. Second is r sine phi, theta unit vector. There is no division. Plus r plus r plus r phi by theta, r phi by theta, dr phi by d theta, theta unit, phi unit vector. Okay, bracket closed into theta. This full is function of theta into theta means theta will become d theta. Now we have multiplication of two vector. One vector is dr by d theta, r unit vector. R and theta, they are independent to each other. If I move the theta, R will not change. It's not Z and X and Y in Cartesian coordinate system, where Z is dependent upon XY plane. R is independent to theta. dr by d theta is 0. Okay, then R sine phi, theta unit vector. That will remain as it is, R sine phi theta unit vector. Plus r phi by theta, dr phi means d phi by d theta. Phi and theta are independent to each other. D phi by d theta will again be 0. Okay, now it remains as r sine phi theta unit vector d theta. Cross product with the another one, that is dr by d phi. Again, phi and r are independent to each other. dr by d phi is 0. Okay, what is next? Next is d d sine phi, d sine, I'm sorry, r sine phi theta by d phi, theta by phi means r d of sine phi d, I'm sorry, it will come as r sine phi d theta by d phi. D theta by d phi again independent to each other, again 0. Now next is r cos r phi vector. That's it, because theta by theta gone, r phi vector. Only r phi vector remained here. This side r sine phi theta unit vector remained. Cross product with r phi unit vector remained. D phi. Here d theta d phi. If someone calculates the cross product of theta unit vector and phi unit vector, it will become r vector. R unit vector, cross product of theta unit vector and phi unit vector will become R unit vector. Now it will become R sine phi into R square sine phi, the R unit vector, R square sine phi R unit vector, and then d theta d phi. Integration, the integration for the theta and phi, because it's d theta d phi. D theta, actually it was theta. D phi, actually it is phi. What is the phi? Phi is 0 to pi. It will not go full. 0 to pi only. Theta will go full. Okay. Theta will go full and phi is 0 to pi. That is the limit for them and they are independent to each other. So integration is theta is 0 to 2 pi. Phi is 0 to pi. R square sine phi. Okay. R unit vector, magnitude R unit vector will go away. D theta d phi. If someone calculates it, will we get the area, surface area? Try it. This is called pseudo multivariate calculus. We started with a simple multiplication of width into length, that is the area, and then slowly we come to equation where to start from theta 0 to 2 pi and phi 0 to pi r square sine phi d theta d phi. We will calculate it. Okay, please do not mind supporting us. Plus 91 is the India. Okay, plus 91 is the India country code 9483160 plus 91 is the India country code 9483160 610 is the telephone number.